Today I'm going to be talking about Graffiti Experiment by Scott McKinsey. So this experiment software is focusing on text entry using handwriting recognition. To run this experiment software, you will have to go to this experiment software page by Professor Scott McKinsey, and under quick access you have to click Graffiti Experiment, which is the third option, and right here beside Windows you'll see two files, graffitiexperiment.zip and graffitiexperiment.jar. Go ahead and download both of these files. Once you go in your download, you should see both files. Under Graffiti Experiment zip, there is all the different text files, JPEG, GIF, etc., as well as the HTML.jar and .java.class files for this software. .jar file is a JavaScript file, so you want to double click to open the Java jar file, and sometimes there might be this window that opens that says it's not open because Apple could not verify the .jar file free of malware, which might harm your Mac. So to do this, just click done, and you will want to go to your system settings, to privacy and security. Scroll down until you see this window that says Graffiti Experiment.jar was blocked to protect your Mac. Click open anyway. Upon launching, the program will show you this missing configuration file window, and this is the .cfg file. Just click yes, and you will be presented with this configure Graffiti Experiment window. This is a program setup dialog. The participant code, which is the first box, identifies the current participant. This is used in forming names for the output data files. Also, the .sd2 output data files will include a column with the participant code. So if you're doing an experiment with multiple participants, you could have the number set up so the files are organized. The condition code, which is the second one, second block, is an arbitrary code used to associate a test condition with this invocation. This parameter might be useful if the software is used as in an experiment where condition is not inherently part of the application. So for example, gender, male, female, input device, gamepad or keyboard, etc. The condition code is used in forming the name for the output data file. Session code identifies the session. This is very useful if testing proceeds over multiple sessions to the progression of learning. The number of phrases is simply specifying the number of phrases presented to the participant in the current block. The phrases file is a file containing phrases of text to be presented to the participants for entry. Phrases are drawn from the file at random. Typically, this very first option, phrases2.txt, is used from a 500 randomized collection of random phrases. The other two files that you can also use are the classic quickbrownfox.txt and alphabet.txt. But we're going to stick with the phrases2.txt. The entry mode specifies the stroke alphabet. Although the software is primarily intended for graffiti evaluations, 3 other modes are supported: unistrokes, digits, as well as custom. So these 3 over here that are all checkmarked should remain the same, but this is going to determine whether or not the presented text is visible during the entry of a phrase. So we definitely want to have the first one checkmarked. Either way, the text phrase appears at the beginning of a trial. If the first option over here is unchecked for some reason on your end, please make sure it's checked off, because the phrase will disappear when the first keystroke is entered. Audio on section is just so you can hear the audible ticks, and this is specifically more helpful when you're using a pen or a stylus-based tool such as an iPad or a Wacom tablet. A slightly different sound, a dong, is heard if the stroke is unrecognized. Lastly, this last checkmark over here that says show gesture set is a checkbox item that determines whether or not an item showing the gesture set is shown in the experiment UI. Click OK. Upon clicking OK, you're going to be seen with this setup dialog, but the application Graffiti Experiment will launch. This over here is a graffiti gesture alphabet. These gesture alphabets were originally created to help those with motor impairments, and it's a very simplified version of the English alphabet in a matter of strokes. And this pink box over here is your drawing box where you recreate these strokes. So where you see the dot is where you would start your stroke. So for example, the letter A, the stroke is on the bottom left, so you start, click, and create the letter, which creates ultimately the letter on your bar. you click and drag left for backspace and click and drag right for space. And we want to go ahead and click begin. This will give you a random phrase from a set of 500 phrases, and this will be displayed at the top text field. The timing will begin at the beginning of the first stroke. So I haven't started drawing any letters yet in the pink screen, so it hasn't started my timing, but this software will time your trials. So I'm going to do this along so I can show you. We're going to basically recreate this sentence over here using the graffiti experiment alphabet here. You can take a few seconds to study and analyze the letters so you feel a little bit confident before beginning to draw the letters on the pink screen. When you feel confident, you will start to enter the phrase stroke by stroke. So the first letter is an S, and I'll draw the S. And as you can see, the software did not recognize my S, which resulted in a G. Simply click drag left to erase it and keep trying. And you will see that entering each letter stroke by stroke will ultimately create this sentence. Sometimes, if the system does not recognize your gesture input, it will also result in a hashtag. Simply click and drag left to erase that. While I'm completing this phrase, I just want to mention that the recognition of each stroke is performed by the recognize method in the UniStroke class, which is already embedded in this software. A lot of users have noted that curved letters such as G or S are harder to input, and it's harder for the system to recognize it. Multiple tries have been done and it's still showing me the wrong letter. So curved letters compared to straight line letters are much harder and more difficult to input and for the system to recognize. Once you are done, you will click the enter button on the right, and the timing will automatically be stopped, and the timing is stopped when enter is clicked. So only click enter when you are done and satisfied with your phrase. The result of the text entry process will appear in a pop-up window after each phrase. So this is an example. It will say thank you, and it will show you the presented sentence, the transcribed sentence of what you drew with the letter gesture input, the entry speed, the error rate, and the keystrokes per character. Although it is not apparent in the pop-up dialog, a number of errors were committed, which were then corrected, and this will be relieved in the high keystroke per character. So my keystroke per character is 2.1176, and this is basically the exact nature of the errors, which will be investigated by examining the output data files, which I'll show later on, through a special trace utility. So we're going to click OK and continue. Again, curved letters, which are curved for some reason, are more difficult to input and more difficult for the system to recognize, which I feel like is one of the flaws of the system, that it shouldn't be an issue for so many people. Enter. As you can see, with each trial, my entry speed improves. So this is 5.92 words per minute. My previous one was lower. That means I'm entering it quicker, and also my keystrokes per character are less as well. Click OK, continue. Another problem with a common curved letter that is not inputting. My S is appearing as a G. I don't know why. Common flaw of the system. This is our last trial. We had set up 5 phrases. So this is our last phrase. Once you click OK after the 5 phrases, the experiment will automatically close. Once you open your Finder, under Downloads, you will see the output data file. So there will be 3 different files. You should see a .st1, .st2, and .st3 file. These output data files are automatically saved on your desktop for a follow-up analysis, and SD means summary data. And these files were created, so we're going to start off by talking about data .st1. So open this, you should see something like this, contains data on a stroke by stroke basis, including timestamps. So this is, for example, the first trial I did, that I do not fully agree with you sentence, and it shows the stroke by stroke basis, and it shows the exact timestamps of how long it took me. This is really good for data analysis post experiment. Next file you should see is the .st2. So a .st2 will appear as an audio file, but once you open it with a text, you would right click open with other, and then simply scroll down to when you see text edit, click open, and this is my .st2 files. .st2 contains the summary data for each phrase, 1 line per phrase. This is an example of the .st2 file. The actual output files used Graffiti Experiment as the base file name. This is also to be noted because this is followed by the participant code, node, condition code, session code, block code, and that's how it's organized over here, what you see. So if you had participant 2 checkmarked, for example, it would look different here. Lastly, you should see a .st3 file, and once you can also open this with text edit, and it should look like something like this. So .st3 is a large chunk of data and numbers, and this is an example as well I have over here, like basically a long list of endless data, and this .st3 contains trace data. So this can be explained as XY sample points for each stroke. A separate utility, the Graffiti Experiment trace. This is basically the trace data for every single stroke that you did. If you open the Graffiti Experiment.jar, you change the entry mode to unistrokes and click OK. Same idea, but this alphabet is a unistroke. So these letters are simplified even more than the Graffiti Experiment. The unistroke alphabets are simple lines. So the A, for example, over here, it's not the letter A, it's one single line. So when you click begin, also there's no backspace, so you have to click the back key button. When you click begin, recreating the sentence using the unistroke is, I feel like, in my opinion, much easier because the strokes are simplified. So there's pros and cons. So for the Graffiti Experiment, the gesture alphabet replicated the English alphabet, which was easier to memorize. However, this unistroke does not have click drag left for back and click drag right for space. You have to use your back key and your space bar to space and go back. And the strokes have nothing to do with the English alphabet, besides, I would say, like L, I, F, but it is purely just lines. So some people find this easier, some people find it harder because it's harder in terms of memorization, but it's easier in terms of execution. And some of the confusing things is that the U and the V are opposite. So the U starts off with the right top and then drag. That's unistroke. I did this I did a comparison study of graffiti versus Unistrokes as a human-computer interaction user study project. And this is a Google Forms that I made and had my participants fill out. And one of the questions in the Google Forms is, have you ever used gesture-based input methods before, such as graffiti or Unistrokes? And out of 12 participants, 11 of them had not used it. After doing 5 trials of graffiti and 5 trials of Unistrokes and comparing the data, I found these results, the participants' averages of stylus-based text entry. So the average entry speed was significantly higher for the Unistrokes one, since it has less strokes. It's simply just lines instead of creating alphabets. It also has less curved letters, and this data analysis shows the graffiti average entry speed, words per minute, the graffiti average keystrokes per character, Unistrokes average entry speed, which is higher, which is the words per minute, and then the Unistrokes average keystroke per character, which is lower than the graffiti average keystrokes per character. And I also did this pie chart, which shows the distribution of the letter difficulties across all participants. Similar to me, 17% of the participants had struggled with creating the letter G. And it is hard. For me, it was appearing as a hashtag, it was appearing as an S, it just wasn't working. And the gesture input is not recognizable by the system. You have to do it a few times for it to work. The second most difficult letter to input was letter O. Again, it was a curvy letter, so it was more difficult for the system to recognize. And the third was an equal tie between the letters S, T, and Y, which each three have 8.5% of participants that struggled with it. I just want to note, for the letter G, 8 different participants from my 12 participants said they struggled with it. My post-user study questionnaire asks the users how difficult they found to understand graffiti keyboard and Unistroke keyboard to be, what they prefer, if they would use it again, if yes, which one would they use again, and whether they enjoyed completing the experiment or not. In summarization, my participants did not find it very hard to understand, but this particular chart was very interesting when 8 people said that they preferred Unistroke and 4 said they preferred graffiti. So 66.7% preferred Unistrokes over graffiti. And when asked if they would use it again, 8 people, 66.7% said yes, and the remaining 4 said no. And if yes, which one would they use again? 66.7, so 8 out of 12 said Unistroke. And also 9 out of 12 of the participants, which is 75%, said that they enjoyed completing the experiment and rated it a 5 out of 5. 2 rated it a 4 and 1 rated it a 3. That was my overall analysis, and some of the comments I received was that the participants found it something new for them to do, and it was interesting to see the different ways the sentences can be communicated outside of using a keyboard to type. They enjoyed doing it. They found it fun to try something new that they are not familiar with. But thank you so much for listening to me, and I hope you take some time to play around with this graffiti experiment by Scott McKenzie, and I hope you have fun doing it and experimenting with a new text entry input method, and I hope you learned something new in my tutorial.